colleagues, welcome to day 2 of our Forecast 2022 virtual conference, Science and Technology, a Driver for Transformation. We are pleased to start day 2 with plenary session number 1 that I will chair, and I will be ably assisted by my co-chair, Sharika Banks, a graduate student at UTech in Jamaica. I know this is the 8 o'clock session, and I see attendees joining. I would like to give a couple more minutes to allow a few more attendees to join us. While we wait, I'll just do a little bit of, let's call it housekeeping, just to give you an idea of how the session will go. Our distinguished speaker, Dr. Judy Lang, who I will introduce very soon, will speak for about half an hour, following which we will have time for questions. And then following the question and answer session, Mrs. Marcia Ford will give the vote of thanks, and then we will bring the session to an end. Okay, I see 20 participants. I think that is a nice round number. And so I will start by introducing our distinguished speaker, Dr. Judith Lang, coral specialist with the Atlantic and Gulf Rapid Reef Assessment, AGRA program. Judy, as she prefers to be called, a marine ecologist who has been energized by reefs in Jamaica and the wider Caribbean for over 60 years, is distinguished as having provided the initial description of a mechanism by which corals compete for space in nature. Judy helped develop AGRA protocols in the late 1990s, and as the AGRA science coordinator since 2005, has prepared many of its instructional materials. After a devastating stony coral tissue loss disease spread from Florida to the Caribbean in 2017 to 2018, AGRA's efforts, and of course Judy's efforts, were diverted to helping regional colleagues respond to this disaster. And then again, when the long-spined sea urchin, Diadema, the region's major reef herbivore, began dying across the eastern and northern Caribbean, including Jamaica, and this was in the early 2022, this year, AGRA remobilized to collaboratively create the open, inclusive Diadema Response Network. Judy actually began her reef explorations in Jamaica, but is now one of the foremost coral reef scientists across the Caribbean. And so it is very fitting that she should speak at this, our first joint UE campuses and UTech conference. And so Dr. Judy Lang, it is my pleasure to invite you to speak about your corals.
Thank you so much. I am a Canadian who had the good fortune to half grow up in Jamaica, and I learned to snorkel at the Port Royal Keys. My first diving was with some very antique aqualung equipment in 1959 off of Port Royal. And that same year I met Tom Garreau, who was a lecturer in the physiology department at Mona. And he was about to become very famous as the most distinguished coral reef biologist of his generation as a result of 2 papers he published on the basis of the PhD research he had conducted while lecturing. And in those days, he had a small wooden boat that he would load up with anybody who could help him on Saturdays, and they would tow it across the hills and dive on the reefs of the north coast, which were closer to shore than the south, most of the south coast reefs around Kingston. And he became quite enamored of them. And by the mid-1960s, he wanted to have a lab of his own on the north coast to be closer to his beloved reefs. So so he got some temporary facilities on the east side of Discovery Bay. And in 1968, Kaiser Bauxite gave a piece of land to him on the west side of the bay to Mona, to UWI, on which he could build his lab. And I tell you all this because in 2018, that new lab, which had been constructed, was celebrating the 50th anniversary of the acquisition of this land. And I was so honored to be present at those celebrations. It was a wonderful week. And I was also present, of course, in Mona for the very first Jamaica Independence Day in 1962. And as you can see, there are a lot more people now, and the trucks are a lot bigger, and the floats are much bigger, and the sound system is also much more advanced than it was in those days. But back to Tom Garreau. One of the reasons he was so famous as a result of his doctoral studies is that he had described in 1959 the 4 reefs on the north coast down to a depth of about 20 meters at most. And in the early days, all of his explorations were done with snorkel, so there was a very limited extent to how deep he could explore. And what he had already demonstrated was that rather than being minor, weak expressions of what coral reefs were like in the Indo-Pacific, they were certainly not as diverse in the terms of number of species, but we now know that, at least with regard to the corals, all those species are endemic to the Western Atlantic, and or at most the eastern side of the Atlantic, with a couple of massive corals. And they were constructing reefs that were just as rugged and fast growing and substantial as anything that was being produced at that time in the Indo-Pacific. So all of a sudden, the Jamaican North Coast reefs were in the literature and in magazines like Skin Diver as one of the premier diving locations in the world and a hotspot for coral reef research. But by the mid-1960s, he had real scuba equipment and was exploring even deeper. And he found the 4 reef escarpment. There were lots of corals there. Deeper at 20 meters, if you went deeper to 40 meters, there were these huge pinnacle reefs standing up above the sand slope. And here he is on one of those pinnacle reefs. And then he went even deeper still to the top of what we call the wall, the deep 4 reef at over the edge of the drop off at 60 meters. And everywhere he went, there were all kinds of wondrous creatures that had never been seen in life before, and in most cases had never been seen before. So this big lump here turned out to be a new species. There were green calcareous algae that hung down from the slopes and walls like bridal veils. And they were these weird and wonderful creatures called calcified sponges that were a mixture of silica spicules in soft tissues that were embedded over a calcareous skeleton. And that just completely blew people's minds when they became well known. Unfortunately, in 1970, Tom Garreau died prematurely at the tender age of 45, just as he had opened the new lab on the west side of Discovery Bay. And here it is a couple of years ago. All those wonderful artwork, the murals on the walls were only added some decades later. But you can see what a improvement it was over the original facilities on the eastern side of the bay. And during the 1970s, you know, the reefs were still marvels to behold. And there were the reputation of the lab And Tom and the reefs drew a large number of graduate students and scientists to Discovery Bay in the summer times mostly to study them. And here are pictures of the outer reef flat where the waves broke, and they were largely constructed of these two kinds of acroporid corals called elkhorn and staghorn because of their obvious morphology. And deeper on the four-reef terrace, there were these huge fields of staghorn coral that kind of flowed around lumpy corals like these star corals and the brain corals. And then deeper still on the pinnacles on the slope, there were thicker, flattened, massive versions of the star corals in shallow water. And on well-developed reefs in North Jamaica at that time, live coral cover, we didn't bother to measure it because it was so great. It was at least, 60% most places and most zones, and over 100% where there was canopy layering of one live coral on top of another and little tiny corals down here in the interstices that you can't even see in this photograph. And the cover of fleshy seaweeds or benthic macroalgae or nuisance algae, they have many names, was less than 2%. We paid absolutely no attention to them. Yet at the same time, we did know that those narrow North Coast reefs were already overfished. We knew that in other parts of the Caribbean, the elkhorn corals were starting to mysteriously die by something called white band disease. And we knew that a herbivorous sea egg, the black sea egg, Diadema antillarum, was very common. And Professor Jeremy Woodley, in a talk to a regional scientific association in 1977, made a point of the fact that Diadema, because of the overfishing, lacked serious competitors for food and had very few predators. And, nobody really paid any attention. And the 70s were, I would say, good years to be a coral reef scientist in Jamaica. And before we go any further, I have to explain what Jeremy meant when he said that the Diadema had few spatial competitors, few competitors for food and few predators. And that is because of the overfishing. There were no big fish around anymore. I mean, it was extremely rare to see a shark or even a grouper that was as large as a Nassau grouper. And as groupers go, they're not the biggest. And there were no big parrotfish either. And what that meant was that there were no large carnivorous fishes to feed on the smaller parrotfish and surgeonfishes and the like, which are herbivores, whose feeding activity helps to crop all those fleshy seaweeds and other kinds of benthic algae on the bottom, which, if left unchecked, can grow faster than corals because corals have to make a skeleton and exclude them. So these are the missing competitors for food. And at the same time, slightly smaller carnivores like the snapper here were also being overfished. And that meant that they weren't feeding on the smaller animals, both fish and invertebrates, that feed on corals. So the corallivores were eating corals probably a little bit out of balance. And did I forget to say that the herbivorous fish were also extensively overfished by then? So only Diadema remained to feed on the benthic algae. And that is part of the reason why they were so very common, but they were probably always common because at least in Panama, they are important in traditional medicine to such an extent that although other sea eggs are eaten, none of the artisanal Indian or later European colonies would ever consider eating Diadema. And why does all this matter? It matters because the net effect is that the corals and these little pink cement jobs called crustose coral and algae are the structural ecosystem architects and engineers of the reef, of the coral reef. And without the hard material constructions that they produce, there is no shelter and space and for all these other creatures to live and flourish. So the food web was very disturbed. And in 1980, the tide turned and started to go out, you could say, because we knew that there was predation on the staghorn and elkhorn corals, in particular by the coral snails. We knew there was this white band disease elsewhere in the Caribbean. And that June, a graduate student taking a course noticed some staghorn corals on the forereef at Discovery Bay that were starting to die in a strange fashion. Didn't look like predation, but it did look like this white band disease in the elkhorn. So we were just beginning to wonder if we were about, what we should do and maybe take it out of the water before whatever it was spread, when on August 6th, Hurricane Allen, that is still one of the largest ever storms to have transited the Caribbean, passed to the north of Jamaica. And these are the 5 meter plus waves the next morning, a few hours after the center of the storm had gone by. And what did the storm do? Well, it's crashing there on the inner forereef and on the reef flat, and it just smashed them to smithereens. If this is what it looked like on one site in 1972 with flourishing elkhorn and staghorn corals, 41 years later in 2013, it still had not recovered, which is very sad. But that wasn't all that happened in the 1980s, because in 1983, those diadema that were so important in keeping the growth of the fleshy seaweeds at bay, suddenly underwent a mass die-off. And that meant that the prime importance of urchins, which is what they are, as a controlling force on the macroalgae to prevent them from overgrowing corals, was readily apparent to all. And what it also revealed is that, we humans were at the top of this food chain, because we were exploiting by eating the herbivorous fish that otherwise would be consuming the macroalgae. We were consuming the predatory fish that would feed on those corallivores, and they're not even here in this diagram. And our development activities on shore and just the growth of the population was increasing the amount of dissolved nutrients that were present in the water. And it turns out that macroalgae can take up nutrients faster than corals. So this was all bad news for corals. And the four reefs in Jamaica, on both coasts, by and large, have not recovered in intervening years. And if that wasn't bad enough, 1987 brought the first of the Caribbean-wide warm season bleaching events. And this is what corals look like when they're bleached. And what does that mean? It means that they lose or have completely lost their characteristic color. And you can see the white skeleton through their tissues. And why is that? Well, we all knew that stony reef building corals, like other animals, need flowing seawater, external sources of food, appropriately warm temperatures. We also knew they needed light. And why is that? And that's because they have single-celled, tiny, photosynthetically active microalgae that live symbiotically in association with the tissues of their coral hosts. And these zooxanthellae, we call them zoox for short, in the light, when they are photosynthesizing, pass some of the carbon-rich materials that they make, and they just pass the simple ones, the simple compounds, to their coral hosts. And the coral hosts use them for all sorts of purposes, to grow their tissues, to deposit in the calcium carbonate in their skeletons, and also to make mucus that is on the outer surface of the coral, not only to help it clear sediments when those are dumped on them, but also the mucus is a good place for the growth of microbes that turn out to be helping protect the coral against some of its microbial predators, because there are also pathogens in the seawater that can kill corals. And the corals in return provide the zoox with refuge from external predators, either in the plankton, or we now know that they can also live on the bottom and on the benthos. And the waste materials that they would otherwise release to the surrounding seawater are passed to the zooxanthellae because they contain, nitrogen and phosphorus and other necessary mineral nutrients for the further growth of the zooxanthellae from the initial carbon-containing compounds that they make. So stony corals grow faster in the light than they do in the dark, and faster than corals that don't have zooxanthellae, which show very little response to light. And that was Tom Garreau's second major contribution to modern reef science. And that paper had the initial paper in that series was also published in 1959. So what does this have to do with bleaching? Well, bleaching occurs when the zooxanthellae are either gone or they have lost so many of their photosynthetic pigments that would normally photosynthetic pigments that would normally color their tissues, that they look like you poured some Clorox over them. And we now know that they bleach in response to many stressors, extremes of temperature or salinity, when there's too much sediment dumped on them, or when the light levels are unusually high. And they're not killed by temporary bleaching. So a huge star coral like this would not be killed by this modest level of bleaching, but the growth of the tissues and of the skeleton over the next few years and their ability to produce during the sexual reproductive season in late summer would be compromised for a few years. And worse than that, in the cases of severe bleaching, they could very well die or become more susceptible to disease. And it turns out that most stony reef corals have a dominant species of zooxanthellae, because not all zooxanthellae are alike. And there may be one species in one genus that's very common in parts or all of one coral before a bleaching event. And then the temperature warms up and the coral bleaches, and then a different kind of zooxanthella that is better adapted to this higher temperature will temporarily replace the normal species, but may in turn be displaced if the environmental conditions return to normal, because although it's kept them alive, the polyps alive during the bleaching event, it's not as well adapted to normal conditions of temperature and light. And it also turns out that severity of bleaching varies by the identity of the coral or its zooxanthellae and where the zooxanthellae are located, both with respect to position on the colony, because light levels change all over a colony, and with respect to its depth and other conditions that affect light levels and ability of corals to feed on the reef. So the appropriate temperature range is critical for the health of reef corals. And these widespread bleaching events that we saw in the years after the first mild bleaching event in 1987 happen when the seawater temperature is above the warm seasonal average, which is defined as shown below, or if it's below the cold seasonal averages. And this only happens at high latitudes in, say, the northern Bahamas or Florida, and is not a factor in the Caribbean. So this is severe bleaching event in 2005. And we all know that global temperatures are rising. We know that most of us probably know that the oceans have taken up over 90% of the heat. And it's become very obvious that bleaching severity depends around the region, depending on the water temperatures at the highest season of the year. And that's not been the same everywhere. So that, but it's also determined by the strength of the ENSO events that occur periodically. So that 2005 was a huge ENSO event, and the whole of the Northern Caribbean and Jamaica were very adversely affected by that. There was a very high risk of bleaching and a very high risk of corals dying because the temperature stayed hot for so long. And the ones that didn't die, many of them, of the more susceptible ones, subsequently died because they got they contracted one disease or another. And you can also see that because the global temperatures are rising, that both the frequency and the intensity of bleaching events have escalated enormously in the 20th century. And at the moment, there's no end in sight. And if we only had to worry about bleaching and warm temperatures, you know, that would be something. But unfortunately, lots of other nasty effects are also contingent upon the fossil fuels that we are throwing into the atmosphere at seemingly abandon these days. And all this carbon dioxide and other greenhouse gases generate heat, and about a third of the CO2 is taken up in the oceans, and it decreases its pH, which means it increases its acidity, and that is turning out to be very bad for sea creatures, and especially their juvenile reproductive products. And along, of course, with the heat and the acidification, we have more hurricanes, and we're seeing sea level rise. And if we only had to worry about, you know, global warming, you know, well, that would be bad, but that's not all, because we also have extensive overfishing, which has only increased in recent decades as artisanal fishermen have got, you know, Yamaha engines have become affordable. And as spear guns have been taken up by young fishermen, as scuba is used by some to collect. These are spiny lobsters. And, you know, these hookah fishing boats have been deployed offshore in places like Pedro Bank, in which air is pumped down from the surface to divers below who are just swimming around with spear guns and collecting fish. But in addition to fishing, we also have, you know, the fact that, as you know, the Caribbean is increasingly relied for income on exploiting the middle-class tourism, middle-class tourism industry with all kinds of effects that are terrible on reefs. You know, land is filled to build huge resorts, reef runways to allow tourists to come in, and of course for local commercial travel, personal travel extend over shallow reefs. And, you know, huge cruise ships increasingly are either anchoring offshore in undeveloped areas, coastlines, such as here, and people in canoes are bringing out the trinkets that they've made to sell them, or, you know, more and more you have these enormous complexes, such as are now found in Jamaica, where the cruise ship industry also has an adjacent port where they sell materials to tourists when they come ashore, and most of that money does not remain in the country. Plus, we have an increase in sediments, and I've already said sediments can be bad. We have massive deforestation for firewood, for agriculture and animal husbandry. We have mining, and all of these activities release sediment and the nutrients that they contain, and lots of other pollutants from pesticides and, you know, materials used for extracting mining ores, and they flow in rivers and underground in the groundwater, and they empty into the nearshore coastal habitats, and eventually, you know, some of them flow out over shallow water corals, and here's a half-dead elk-horn coral after a big rainstorm released a bunch of sediment from a road under construction in the Eastern Caribbean. And then you have African dust. And I haven't even mentioned sargassum, but Prof. Weber can tell you about that. Along with sediments, we have increases of sewage with poorly treated or even raw sewage flowing into the nearshore ocean from lots of sources at many stages of technological advance, from simple sewage pipes to huge subsurface ocean outfalls. And they're all releasing nutrients that are fueling the growth of slimy filamentous cyanobacteria that overgrow the benthos, including any corals or soft corals as are attached to the bottom. And they have pollutants of all kinds that, we don't even know what most of them are. And with the result that in areas that are adjacent to large outfalls or to a bunch of inlets in which the poop, as it's called, is flowing into the ocean, if a coral on the bottom gets sick and gets a lesion, maybe from a fish bite or something like that, they have a long time before they recover. So lesions tend to become permanent. Corals are, it turns out, immunocompromised to the extent that they cannot repair tissue damage nearly as much as they do on reefs that are not so polluted. And all of this, activity with tourism and population growth and coastal development, depends for the most part on shipping industry. So you have barges of all sorts, dredging from clearing small inlets like this to huge dredgers that, maintain large ports and dig channels that are large and long and wide and destroy everything in their path in the process. And then you have oil spills that can be chronic wherever there's regular transfer of oil from tankers to shore, or catastrophic when one of those tankers occasionally bursts. And you even have when large vessels go aground on shallow reefs, they can excavate a trench, not just through the overlying corals on the bottom, but also dig out the underlying reef consolidated framework, which takes a lot of energy. So is there any wonder that the live cover of the star corals at Dancing Lady Reef, where you saw a lot of those earlier photographs from Discovery Bay, at 7 meters in 1972 was about 25%. And that wasn't the only corals down there, because between those star corals, there would have been other rain corals, but most importantly, there would have been a huge fields of staghorn corals. So the total cover was well over 50, maybe 60%. Although not at that time measured. And at 30 meters, where you had those deeper, massive flattened plates of star corals, in 1972, it was 53%. But 41 years later, in 2013, at both areas, when the same transect locations were resurveyed by Phil Dustin, the cover had fallen to 6%, which is all pretty grim. And you would think we'd had enough problems, but in 2014, a brand new disease called stony coral tissue loss disease turned up in Florida. And 3 years later, a few colonies on the north coast of Jamaica started to look sick. And by the spring of 2018, it became evident to a few sharp-eyed folks like Andrew Ross off Montego Bay that stony coral tissue loss disease had indeed turned up in Jamaica. And by summer, it was everywhere along the north coast. And this is an incredibly dangerous disease because it affects probably as many as 36 coral species, and we say about because there is some uncertainty about the boundaries of some species. It causes rapid tissue mortality, as you can see here, and colony death of the most susceptible species occurs within days to weeks to a couple of months. And the less susceptible species, like our star corals down here, take longer to die and are less likely to completely perish, and maybe only 40 to 60% will be lost. And these other highly susceptible species include a bunch of brain corals, like the ones across the top here and down here in the lower right, that maybe 80% or so of them will die. So it has huge, huge, huge effects on the four-reef populations that were, after the loss of the elkhorn and staghorn colonies, mostly consisted, the framework building species were these kinds of massive corals. But fortunately, it doesn't seem to affect the acroporid corals. So the surviving elkhorn and staghorn are still with us. And in fact, over the last few decades, there has been great success made in replanting surviving elkhorn and staghorn corals, growing them in nurseries and then planting them out in areas where they used to flourish. And in some places you can't tell that the replanted nursery corals haven't been there forever and are natural recruits. So there's bad news, but there's also some encouraging good news. And I'm really encouraged to say that rescue of surviving fragments of these SCTLD susceptible corals is also now beginning. So that's been ongoing around the Caribbean since, some magnitude, since 2018, and everywhere except the southwestern and southern part has been affected. Over 20 jurisdictions altogether in the last 4 years. But that's not everything, because this spring, the Diadema, which had been starting to come back in some areas and more successfully in Jamaica than most, also underwent their own second mass die-off. And when I say mass die-off, it means that if this disease, which is still being investigated, arrives up to, it looks like 98%, 99% of the adult urchins die. And the juveniles, the extremely young recruits, are too small to see them very easily. You can see one here on a artificial substrate. And their normal inclination is to hide out in the deep crevices of the reef and stay away from their predators, because there's lots of fish and invertebrates that like to feed on them when they're young and tender like that. And they only normally come out in the open like these guys do when they're more mature, or in the open in the daytime. And remember, they are herbivores, so they have to move around at night to feed. But they started to sicken and die, and in a matter of 4 months, over 20 jurisdictions, sprinkled around the northern and eastern Caribbean, had all been affected. So it was popping up very, very quickly all over the place. And once they look sick, they're dead within a day or two. So this is a rapidly spreading disease. And when it comes, it's, you've got it. And pretty soon, it looks like they're all gone. But again, there are some survivors. And a couple of months after the disease has worked its way through the visible population, it seems that some of the adults were also hiding out in the interstices of the reef. And they are now beginning to venture out into public view in places like Jamaica and Dominica and Puerto Rico and Martinique and Guadeloupe. So that's all very encouraging. They didn't all perish. And there are also natural recruits that are turning up. You can now see them emerging a little bit from the hidey holes in the reef crevices. And these are small enough that they must have recruited from larvae that were in the plankton this spring. So that's also good news. And just like there is, rescue and nursery and replanting of stony corals, animal husbandry has begun for Diadema. And here is a small aggregate of Diadema. Their larvae were collected on plates and grown up in a tank in a wet lab. And when they were a year old, they were put out on a reef that also was being restocked with a species of stony coral tissue loss disease that was additionally being rescued. So there's bad news and there's good news all the time. The glass is always half empty, which means it's always half full. So Jamaica at 10 meters in 2020 in the area around Discovery Bay, there actually was a lot of spatial variation in the appearance of the reef, which also gives me hope for the future. And we can just look at 3 sites: Discovery Bay itself, to the west, a few kilometers, Gorgo City, and further west on the western side of Rio Bueno. And the coral cover increased from Discovery Bay to West Rio Bueno by almost, an order of magnitude, from 2% to 36%. The fleshy algal cover decreased, not as much, but by half, about, or a little more. The number of herbivorous fishes expressed as grams per 100 meters squared increased from 165 to 917. That's good. And the biomass of the carnivorous, the major carnivorous fishes, increased by 100 times, or is that 1,000, from 18 to 1820 across that very same small spatial gradient. And the density of Diadema was an order of magnitude greater at West Rio Bueno than it was in Discovery Bay. And it was, 2.5 times greater, or 29 times greater, nearly 30 times greater at Gorgo City. And the effect on the reef was, visible at first sight. There were Diadema in the interstices, and their feeding activities were keeping the fleshy algae under control, and the extra fish that we don't normally see around most of Jamaica were starting to come back. They weren't very large yet, but there were enough of them that this mattered. And here's a view at West Rio Bueno. And, we know these areas were affected by stony coral tissue loss disease like everywhere else, but they don't seem to have been affected as badly. And we also know the water quality here is better. The water is bluer. You can tell it's better quality. So there's presumably less nutrients and pollutants. And, there is hope for the future. So, my final words this morning is that, to sum up, to say is that, we've created a whole heap of plenty, deep trouble for coral reefs, as well as the oceans, the rest of the oceans and the whole of Earth. Yet not all is lost, but we could try harder to redress these wrongs. And that's why I'm so happy to talk to, the scientists and technologists at the conference this week, because, any of you who have a concern for nature, you are most welcome to join us and help us search for more sustainable and equitable solutions, and not just for nature, but also for humanity, because, we're all on this together. And thank you very much.
Thank you so much, Judy. That was a tremendous talk. A lot of bad news, but you ended on a tremendously positive note. And we take your charge very seriously. I mean, this conference is science and technology, a driver for transformation. we need to harness some of our science and technology to work on some of the issues you have raised. And so you talked for longer than you had planned, no worries. But we still do have some time for questions. And so I wonder if any of our participants or panelists have questions at this time. Or comments. Okay, I see one question in the chat from Nicole Robinson. She says, is there any research being done on what is causing the Diadema die-off?
Yes.
If we do not find out, there can be much more. Right.
We hope we will have a good idea fairly soon. And this is a wonderful success story because, you know, the Caribbean and Bahamian governments have become appropriately very concerned about international outside, unfortunately, you know, scientists coming down and collecting organisms and extracting their DNA and going off and setting off companies and making fortunes from the genetic biodiversity that came from the country that the specimens were collected. So it's getting very, very, very hard to get permits to export genetic materials out of these islands. And for the stony corals, well, they're all CITES listed, so that's really difficult. But even for the diadema, because people understand how valuable they are. But yet, when in the middle of March, when it was suddenly apparent that, you know, across the northern Eastern Caribbean and Jamaica and Mexico, all the way from the U.S. Virgin Islands and St. Barth to Jamaica to Cozumel in northern Mexico, diadema were suddenly dying, and they were the major herbivore. You know, everyone was terrified, to put it mildly. And I was able to arrange for local people to collect tissue samples, both for histopathology and for genetic analyses, molecular analyses, microbial analyses, and all the modern benefits of high-tech science, and to get permits for them to be sent away to the US for analyses. And those analyses are well underway at the moment. And really, we're waiting on the histopathology to see what these urchins look like when they're dying. And this was a lost opportunity in 1983, in part because the technology didn't exist back then. And in part because we just weren't prepared to do anything that amounted to anything that meant anything, so that the little tissue sampling that was taken, you know, wasn't good enough quality to say anything very much. So we are really, really hopeful that, excuse me, that we will be able to pinpoint what this time is responsible, and if it's varying across the region, because it does kind of seem as if there might be something in the environment that is already present and primed to kill them, and you just need the right stimulus to set it off. And so when you were talking about, you know, these transient events like upwelling that causes a sargassum to bloom some years more than others, we're kind of hoping that we will be able to find some environmental correlate to help explain the patchy distribution of the die-offs as they actually occurred this spring. And that's what I've been doing for the last 6 months.
Wow. There's several other questions and comments, compliments that of how informative the talk was. Andrew Lamb asks how to join the efforts to save our corals. I'd love for you to save that to last, though, Judy.
Oh, go talk to the marine scientists.
The other question, growing these species.
So, well, let me just give you some names. And of course, talk to Professor Weber. But at UTEC, there is Christine O'Sullivan, who is a lecturer. And at UE, there's Dr. Suzanne Palmer. Go talk to them and offer your services. And, you know, you may, if you're a technologist or some kind of applied scientist, you may have an idea to offer that exploits some kind of modern approach that they've never heard of. So you may have to explain, you know, you may have to educate them about what you can do, but don't hesitate to go interact with them if you can.
Yes, indeed. Okay, the other question, growing these species in the laboratory and returning them to the ocean seems unsustainable. Is this the only way? Only mitigation?
You know, that's begging the real question is, why are they so immunocompromised that they die so easily these days? The temperature goes up a little and they grow. Something comes along, some pathogen comes along they haven't seen before and they grow. Now, why is that? And it's because, you know, as Phil Dustin says, it's everything. It's the warming, it's the pollution of all manner of sorts. And you know, there's thousands of chemicals we're putting in the ocean, and most of them we have no idea what they do. So we've got to join forces and start to combat the excesses of modern technology-based life.
Has our world become too harsh for the genetic group of corals that we now have?
Yeah, well, let me say, corals will survive us, or something related to corals will survive us.
Absolutely.
They are cnidarians. Reef-building cnidarians of one form or another have been around for the last over 500 million years. The corals that we see today have been around since shortly after the end of the Permo-Triassic extinction about 245 million years ago. Their ancestors, not them, but their ancestors have been through all kinds of crises in the past, most of which did not occur as quickly over the time scale as the current crisis, with, you know, the big exception of the asteroid that crashed into, you know, the Mexican peninsula at the end of the Cretaceous period. So they will survive. You know, honestly, we really need to be more concerned about the survival of our species, because we haven't been around very long. And, you know, we're the only surviving species that we know of at the moment. So we need to do this, not just for nature's sake, but for our own future generations, and thinking not just of our children and grandchildren, if we have any, but, you know, well into the future.
Yes, thank you. Thank you so much for that answer. I have two other questions. We have time for a couple quick questions. An anonymous attendee has asked about outreach activities that may be happening with stakeholder, fishermen, government, hospitality industry, retailers, etc., to inform and educate.
Yes, that's a huge growth industry, and we're not doing a very good job. I mean, we are cleaning up at the edges. There are fisheries improvement projects in Discovery Bay, which were started by Professor Woodley back in the 80s originally, and lapsed, and then were taken over and became fish sanctuaries. And, you know, depending on local economies, they wax and wane. When there's money for rangers, fishermen can be motivated to become a ranger and stop fishing and chase out other illegal fishers if it's in a fishery, in a fish sanctuary. Around the Caribbean, in many countries, when COVID, sorry about that, I can't stop the pendulum clock on the wall, and it's 5 minutes fast.
That's okay.
COVID also descended on us in spring of 2000, and for 2 years, the tourism industry was in severe stress around the Caribbean. And many countries were food limited. People could not, import food. Countries could not import food to feed all the population any longer. And so a lot of illegal fishing took place. And a lot of it was concentrated in the fish sanctuaries because they had the most fish. So we have lost a lot in many areas. And I don't know what the data will show for Jamaica, but it is substantial in places where it is known to have occurred and did happen. So there are limits to our outreach when in times of hardship as to what we can do. But there is, and there were posters in at least 4 languages that I can think of for the Diadema this spring when they were suddenly dying. English, Spanish, Dutch, and French. When just sort of magically appeared all over the place, asking people to be on the lookout and to report observations. And so, yes, in an emergency, you can get a good response. But day to day, it's really hard when it's impacting your ability to feed your family.
Yes, indeed. And locally, we have good networks, but AGRA and other such networks really help to pull the Caribbean together. And so the last question from Dr. Curtis Busby Earl is asking, what is mentioned about the northerly islands? Is there any data on the islands in the southern Caribbean, such as Tobago, where there are large braying corals and increased tourism-related activity?
I can tell you that there is neither stony coral tissue loss disease nor the diadema have not died
In Tobago.
In Tobago, at least so far. Now, the stony coral tissue loss disease was sort of slowing down as of a year or 2 ago. It was still expanding locally, but it wasn't, invading too many other areas. But last week, out of the blue, it reached Antigua, which was about the only place in the Northeastern Caribbean that hadn't been affected to date. And it's still apparently maybe popping up. The Diadema die-off may also still be popping up, even though we hadn't seen any new outbreaks since late May. So these are they are not endemic everywhere as yet and still expanding their range in a few places, unfortunately.
So it's great. Tobago is still in good condition. Okay, well, we are almost out of time. And I thank you so much for an amazing talk. Historically, very, very important to know where we have come from and how quickly we have gotten to where we are. And I will ask Ms. Marcia Crary to quickly wrap up our session and give the vote of thanks. Thank you.
Okay, on behalf of the UE UTech Forecast 2022 conference organizers, I would like to express our sincere thanks for you to agree to address us this morning. Of course, you're no stranger to Jamaica, the University of the West Indies, the Center for Marine Sciences, and of course, Discovery Bay Marine Lab. And we are so happy to see you again.
Thank you so much. And the dog was supposed to be outside.
No problem. The coral reef scientists throughout the Western Atlantic and Caribbean are all very familiar with the AGRA program. And we are also aware that you have been involved since the mid-90s and you continue to be an integral part of that program. And Jamaica has always also been involved with the assessing of coral reefs using the AGRA method. And many of us, including myself, have been trained in using the AGRA method for monitoring, and many of us continue to do so. We thank you for reminding us of the history of coral reefs research here in Jamaica, particularly in Discovery Bay, and how important Jamaica has been in coral reef research, both for the Caribbean and globally. So your presentation on Caribbean coral reefs are in deep trouble, but is not yet terminal, was very insightful. You are able to lay out the trajectory of their decline, and I will list them here: overfishing, coral disease, predation, hurricane, sea urchin die-off, bleaching, global warming, mass tourism, land-based pollution, shipping, and the latest is stony coral tissue loss disease. So the list seems endless, but also you gave us hope that all is not lost. So some of the things that you highlighted that were taking place: restoration and replanting of corals, especially the acroporids, the rescue of susceptible coral species, the nurseries and natural growth of sea urchins. And you indicated that some areas in Jamaica were in fairly good condition, areas that had good water quality, increased biomass of herbivorous and carnivorous fishes. So we are grateful for you for demonstrating that the field is wide open for researchers to find solutions for coral reefs, not only coral reefs, but for nature and humanity. And in your words, as you said, so we need to talk to a marine scientist. So with that, I would like to thank you and all the best.
And I should have put up my email in case anybody wished to contact me. But you and Professor Weber can always pass it out.
Yes, indeed. Thank you, everyone. Thank you, Marcia. Thank you so much, Judy. And I turn now over to the break.
Yes.
The conference. Thank you.